Hello, pre-algebra, Mr. Lawrence here with your flipped lesson for Wednesday, March 21st. And today's lesson is going to be on dilations. It's another type of transformation. And it is important to know to dilate means to get bigger or smaller. And when I do this, the shape must be proportional. It must be proportional. Right now, these two stars are congruent, yes? I can dilate this one. And look, it's a similar figure. It is proportional. It would be an exact copy of a smaller size. That is a dilation. In fact, I'll tell you what, I'll make it red so that you can tell which one I'm talking about. So it's filled red. It is an exact copy. Or I can dilate it the other way around, and yet it stays proportional. Oh, you can't see it, silly me, and this won't work either, will it? Unless I do this. Haha, I fooled you. Order, bring to front. Boom, there it is. The original is inside the red star. No, I am not a communist. Okay, so when we do a dilation, we're either going to make it larger or smaller, but it's going to stay proportional. And there's going to be two different types of dilations. The first type is, I want to say here, two types of dilations, right? Two types of dilations. Oh, by the way, I do want to mention some of you are not making up your quizzes and tests. They will turn into zeros. Just so you know, I will be calling home on some of you. All right, two types of dilations. The first type we're going to look at is when you dilate about a point. Oh, not a point. A point of polygon. And this is cake. This is so easy. Let's say I give you a triangle. All right, so let's find a triangle. And I have this one. And you know that this is point P, this will be point Q, and this will be point R. Okay? And I tell you to dilate this triangle with a scale factor. I have to tell you the scale factor. I have to tell you the scale factor. I have to tell you the scale factor. Scale factor of, say, 4 about point P. All right. What this means is that this triangle is going to grow longer by a multiple of 4, but P is going to stay stationary. So I'm going to group these three together here, group 4. All right, and I'm going to move them on down a little bit and see what's going to happen when I do this. If I do it right, is that this triangle here is going to, let me clone it. All right, and I'm going to change its color. There we go. And it's going to get bigger. But it's not just going to go any old way. When it gets bigger, P is going to stay in the same spot. See, P is going to end up like that. All right. So scale factor of 4. Now, I need to tell you that, say, let me get rid of this orange one for a second here. Just move it out of my way. Okay. And I tell you that this is 5 centimeters. Okay, and this is going to be 12 centimeters. And hold on one second. Okay, I'm using a scale factor of 4. All it means is I'm going to take this number here, this 5, and I'm going to multiply it by 4. 5 times 4 is going to be 20 centimeters. All right, I'll take this 12 and multiply it by 4. And I will get 48 centimeters. And that's all it means. So they might give you something like this, where you have a triangle. Okay. And they tell you to dilate it, sorry, that should be a Q there. To dilate this with a scale factor of 1/2, about point R. In this case, R is not going anywhere. So maybe I'll make this side of the triangle, I don't know, 12 inches. And I'll make this side, it's about the same. We'll go 16 inches. Oh, excuse me, I should do the other side. Okay, 16 inches, right? Well, what's going to happen is this triangle is going to shrink down. Remember, dilate can mean get larger or shrink proportionally. So P is going to become P prime. And I know how long this is going to be because I'm going to do 12 times the scale factor. 12 times 1/2 is 6. So that's going to be 6 inches. All right, Q is going to slide here. And I know the length of Q because I'm going to do 16 times the scale factor, and I'm going to get 8. Right? 18. Oh, 8. I said the right thing and wrote the wrong one. Excuse me. 8 inches. That means this is going to be 8 inches long. And then there's my new triangle. So that's one type of scale factor where you take the measurements of the sides and you multiply by whatever the scale factor. Excuse me. That's one type of dilation. One of the points of the polygon will not move. Okay? Now, there's another type of dilation, and this one involves coordinates. And in some ways, this one's easier. So, this is the second type of dilation. And this one has the origin at the center. The origin is at the center. So give me 1 second here. Okay, so I've got this triangle ABC. Let me draw its segments in here. All right, I think I forgot to label C. I'll have to get that on there as well. And I'm told I want to dilate it with a scale factor. I'll make the scale factor, SF will be scale factor. I'll make it 1/5, 1.5. All right? And I'm going to increase this to the scale factor 1.5. The origin is going to be the center. This way is easier. All I do is take each of the coordinates and multiply them by 1.5. So A prime, 2 times 1.5 is 3. 3 times 1.5 is 4.5. So A prime shows up at 1, 2, 3, 1, 2, 3, 4.5. There's A prime. All I did was multiply each coordinate by the scale factor. Okay, this is when the origin is at the center. 1 times 1.5, 1.5. 5 times 1.5, I think, will be 7.5. All right, for those of you wondering how I'm doing that so fast, I know that 1 times 5 is 5. I know that half of 5, 0.5 of 5 is 2.5. 5 plus 2.5 is 7.5. So B is going to go to 1.5. 1, 2, 3, 4, 5, 6, 7.5. So there's a new B prime. All right, and then C prime, 4 times 1.5. Well, 1 times 4 is 4. Half of 4 is 2. It would be 6, and of course 6. So C will go to 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There we go. C prime. See how simple that is? There's nothing to it. So let's say, or let's just review really quick. We had 2 types of dilations. The first type is when one of the points of the polygon or the shape is the center. Like in this black triangle, P is going to be my center. Okay, so P prime and P end up being the same point. All I do is multiply the length and the width, or the base and height, by the scale factor. Then I know the new triangle. And it would actually move over here and be like that. Okay. I'll change that to orange so you can see which one it goes to, and change that to orange and put that on the appropriate side. I multiplied 5 times 4 to get 20. I multiplied 12 times 4 to get 48. Oh, I don't know why that's centimeters squared. That's a silly mistake. Sorry about that. And that gets me Q prime, R prime, and P prime. And notice P and P prime are the same point. So when we do it about the point, it just stays where it's at, and then we multiply the sides, and that moves the other side, the other points out. Then there's a type where we use the origin as the center. And in that case, we list the coordinates, we multiply each coordinate by the scale factor, and that's how we get our new coordinates. All right, so tomorrow we'll have a little formative assessment to start with. Those of you that know how to do this right off the bat, you won't have to worry about sitting through another lesson. You can start your homework, get it done, go out and enjoy the nice weather. Those of you that need a little help, I will help you. Those of you that aren't watching the videos, oh well, you won't know what'll happen anyway. Talk to you later. Mr. Lawrence out.